So for this problem, I have two options. I know I want the bases to be the same. One option is I could go 2 to the 4th and 2 to the 6th. Another option is 4 squared, 4 cubed. I feel like this is easier because it's smaller. So I will pick that. So I'm going to go 4 squared, but then I have to multiply by 5x. Make that a little bit bigger. And then 64 is 4 cubed times x plus 7. So don't forget that. Now, bases are the same. Boom. 2 times 5x, 10x, equals 3x. Don't forget to distribute it to both. Common mistake, you're just going to write 3x plus 7. Now solve for x. X equals 3. Okay, I didn't need logs for that. There were no logs needed. It was all exponents, so it was great. Now I look at this one though. This one's a little bit different because here I was able to make the bases the same. Here I am not able to make the bases the same. Since I cannot make the bases the same, I'm going to have to log both sides. And when I do that, I get little turns big, x plus 1 log 2. Little turns big, 3x log 12. Okay. There are a couple different ways to do this problem. For me, because this is a decimal and this is a decimal, I prefer getting the logs on the same side. So I'm going to choose to move this one over here. So then I'm left with x plus 1, so I'm going to divide by log 2, divide by log 2. So I'm left with x plus 1 equals 3x times log 12 over log 2. Okay. So now what I'm going to do, because I can't do anything else, this is a number, this is a value. I'm going to take this value and I'm going to multiply it by 3, so it's going to be something x rounded to the nearest hundredth. So we're going to be careful about that. So I'm going to go like this. Let's see, log 12. Don't forget the parenthesis at the end. Divided by log 2. Now you're going to write, it's 3584, but then you have to multiply that by 3, and rounded is about 10.75. But my issue is you want to make sure that it's a whole number. So we have a 1. So what I'm going to do, let me move this up here. Sorry, I know I'm out of space. And gosh darn it, sorry about that. 1x plus 1 equals 10.75x. And what I should have said is that you want to make sure it's the perfect answer. So I'm going to keep this perfect answer, and I'm going to subtract 1x. And I get 1 equals 1075 minus 1 is 975. So I'm going to subtract 1 in my calculator so it's perfect. Okay. Now I have to finish by dividing by 9.75, 9.75. So I want to make sure that my answer is perfectly as rounded, just like mine. So that means even though you're writing this like this, you're going to keep the perfect answer there. And in the calculator, you're going to go 1 divided by the answer that you got. And if you look right here, see it says ANS. So you're going to go second negative, and then I get 10. Wonder if it worked out if you wouldn't have rounded. Let's see. Oh, I guess it ended up working out. So then you can just go 1 divided by 0.975. You didn't have to do what I did. Okay. So let me go over a different example just like that one. So let's say I had 3 to the x. Let's go 3 to the 4x equals, I don't know, 10 to the x minus 1. So what I would do is I would log both sides because I have no choice. Little turns big. Little turns big. Excuse me, sorry. I'm actually going to make this on 11 because if it was log 10, it would be no problem. Sorry about that. Log 11. Now, remember in the previous problem, I moved this one over here? I'd actually prefer to move this one over here. And the reason is, if you remember up here, I had to take this and multiply by 3x. If I would divide this one over here, I would have to distribute it to this one and to this one, and it would cause more heartache. So in the end, what I'm saying is, move this over to the one that only has one term. It's easier. log 11, log 11. So I'm left with 4x log 3 log 11 equals x minus 1. Now I'm going to go log 3 divided by log 11 and multiply by 4. So I go log 3 divided by log 11 and then multiply by 4. And it's 1.83x equals x minus 1. There's an imaginary 1 there. 0.83x equals, negative 1 divided by 0.83. And so I go negative 1 divided by 0.83. And I get x equals negative 1.20. Now what I want you to see is if I would have instead taken this problem, and instead of dividing by log 11, if I would have divided by log 3. Let's pretend I decided to do that. Then I'd be left with 4x equals x minus 1 times log 11 divided by log 3. Then I would have to take that value, log 3, and multiply it by this and multiply it by that. So I'd have a decimal x minus another decimal equal to this, equal to 4x, then move this over with the decimal. It's just too much. So I feel like it's easiest to do the one with one term. Okay. All right. There are different ways to do this problem, but the way that I would do this problem is, the moment I'm in log form and I see something little, I want to make it big. Now I have a number on the outside, divide by 6. Log 3 to the x equals 2. Now, I did as much as I could in log form. I can't do anything now. Now I'm going to change it to exponential. Okay. Now, some of you might want to do this. Go straight to exponential form. The problem with going in exponential form is you have to make sure you make this exactly the same. So I couldn't make the bases the same because this is a letter and this is a number. But I could make the exponents the same by doing this. I'm just showing you a different way. If you don't know what I'm saying, then just move on. See how these are the same? So then I can just go 3 squared equals x, which is what I had here, and then x equals 9. You can do that way. If you don't know what I'm talking about, you simplify log form as much as you can, and then you change it to exponential form. All right, let's take the next one. This one, whenever I see minus, I'm automatically thinking divide. Now, I can't do anything more, because if I tried to simplify this, so if I tried to go x over x plus 9 and simplify that more, that would be 1 plus x over 9. And that doesn't make my life any more simple. So there's nothing else I can do in log form. It's as simple as I can go. So as soon as I do that, I know it's in base 10 because I don't see a base. This one was in base, where is it? This one was in base 3, so no problem. This one didn't have a base, so it's base 10. Now boom, exponential. 10 to the first equals x over x plus 9. 10 to the first is 10. Multiply both sides by x plus 9. A mistake you're going to make is you didn't distribute it to both. So distribute this to this and this to this. So I'd be left with 10x plus 90 equals by x. Move this over. 90 equals negative 9x. Divide by negative 9. X equals negative 10. Okay. And we're good to go. All right, let's try the next one. This one is similar, this one right here, is similar to this one. But this time, instead of subtracting, I see adding. So instead of dividing, I'm going to multiply. So I'm going to keep this side the same. I'm going to multiply. I'm going to rewrite this left side. Nothing I can do on the left side. Distribute, distribute. Now, how can I change this to exponential form if there's logs on both sides? You can't. But you know how the bases are the same in a sense? The bases are the same. Just like over here, the bases, where are we? We made the bases the same. And once the bases are the same, you just compare the exponent. So I'm just going to take this and set it equal to this, and then solve. I'm going to add 6x, add 8, and I end up with 7x equals 20, x equals 20 over 7. Okay. Hopefully I did that right. I went a little bit fast. All right, next problem. I have to either use this, this, or this to make them equal, so I'm going to have to compare them. So I'm going to go to this side, little gets big. This is 2, that's 2 cubed. That little gets big, times 1 is 6. So this side is 6. I know that when I'm adding, it really means multiply. Log 3, I think it's 3 to the 5th. 5 times 1 is 5. Do you need to show all this work? Yes, you do. I want to show you, if you want to, you didn't even have to put those together. You could have gone log 3, 3 to the 4th, and that would be 4. This would be log 3, 3, 1, and 4 plus 1 is 5. Either way, this side is bigger. You're good to go. Last problem. All right, graph it, state if it's growth or decay. So it's decay because of this, because 0 is between 0.92, which is less than 1. So I want you to be clear. That has to be the justification of decay. All right, I'm going to plug it in. I know anything to the 0 is 1 times 17 is 17. That one's not a big deal. So I'm going to do this one, the calculator, 17 times 0.92 to the first, which I know is 0.92, but whatever. So 1564. I don't have to rewrite it. I'm just going to go. If I press the up button, I can just copy it. Round it to the nearest hundredth is 14.39. Round to the nearest hundredth. Press the up button. Oops. Oh, it go to the previous one. Interesting. -1. 1848. Then press the up. Over. 2 is 20.09. That makes sense because if it's decaying, it's going down. So now I'm going to graph it. I see it's between 0 and 20. So I'm going to go 5, 10, 15, 20. I'll just graph the 1 and the 2 because I didn't really give you space. 0, 17 there. 1, 15, 64 here. 2, 14, 39. And I know it's going to be decay. Okay, that's what I want. If you want to graph the other 2, you can, and it'll continue like that. The last thing I have to do is create a situation. All right, I've invested $17, and I am losing 8% every month. Okay, obviously write something a little bit nicer than that. I've invested $17 into the stock market. Unfortunately, my balance is depreciating by 8% every month because this was at 100%, but now it's at 92%, which means you lost 8%. And that's the quiz.